Hello my dear friends, I welcome all of you to this IMS Gate Academy, and you know that we are continuing the smart revision series on industrial engineering that we have started 2 days back, right? So my dear friends, I am sure that all of your preparation is going right on track, and you are utilizing your every day to revise more and more, right? So without wasting any time, let me tell you that yesterday we started with inventory and inventory replenishment model, infinite replenishment model we completed, and today we are going to start with shortage model, and today the entire 1 hour we are going to utilize in learning the inventory basics, right, and the important stuff that can come in the examination. So my dear friends, shortage model. So yesterday when we learned the infinite replenishment model, we assumed that there is no shortage, but now what we will do, we have to assume that there is shortage, right? So let us see how this model is working. So you know that, let's say you have ordered Q units. So Q units will be over here. You have received the order. Now you are consuming at a constant rate, of course, and now you are allowing some shortage also over here, and once the order has come, and again it has risen up to this level, So the question is that whatever you are ordering, is that going in your inventory? No, it is not going, because some shortage has been compensated. So this is your shortage, right? This is your shortage, and this is your maximum inventory. This is your maximum inventory that is building up. Clearly I can say that IM plus S is equal to W, is equal to Q. IM plus S is equal to Q, right? Now my dear friends, I can say that we are consuming at a constant rate of D, and the moment where inventory is there, the time till which inventory is there is T1, and the time where T2 is there, shortage is there, is T2, and this entire constitutes your cycle time. This entire T1 plus T2 will constitute your cycle time, right? So this is your one cycle that you are looking on. As I already said that we should always remember the figure in case of inventory, and you can clearly see that I am seeing 3 triangles over here. What are the 3 triangles? So one big triangle that you are seeing for covering the entire cycle time. So Q is equal to capital D into your TC, I can write. This can be my equation 1. Then see this triangle where inventory is there. This triangle. So what is this height? This height is IM is equal to capital D into T1, I can say. And this is small triangle, I can say S is equal to, the rate is D into T2, right? And don't forget, this entire is your Q. This entire length is your Q. So finally I can say Q is equal to IM plus S. IM you can say the maximum inventory. So these 4 relations should always be in the back of our mind. Right? So why we are saying like this? Because he can ask you what is the T1, what is the period where shortage is allowed. So all these things he can ask you. And what are the types of cost? The total inventory cost, or I can say the variable cost over here is nothing but the ordering cost plus then there is holding cost and plus then there is shortage cost. So what is ordering cost? Ordering cost is number of orders into ordering cost. So number of orders will be what? Your annual demand is D. On one hand you are ordering Q into C naught. What will be your holding cost? What will be your holding cost? So I told you yesterday that it is the average inventory. It is the average inventory into cost of holding per unit per item. So for average inventory, I told you that we have to, I gave you a formula yesterday, average inventory, I gave you a formula yesterday that the area till which inventory is there, that is half into IM into T1 divided by the total cycle time, and that is TC. So it is nothing but IM by 2 into T1 by TC, and T1 by TC I can very easily find from here. T1 by TC I can say it is nothing but IM by Q. So it is IM square by 2Q, and in place of IM I can write what? Q minus S whole square by 2Q. Yes or no? This becomes my average inventory. Similarly, I can very easily say that what will be the average shortage. So average inventory is what? Average inventory is IM square by 2Q into CH, and similarly what will be the average, the shortage cost? The shortage cost will be average shortage into CS I can say. So average shortage, like this only we have to write, that wherever shortage is there by total cycle time, so it will be S half into S into T2 by TC. T2 by TC can be written as, T2 by TC can be written by S by Q. So it will be S square by 2Q into your shortage cost. So now my dear friends, if I write the total inventory cost, if I write the total inventory cost, so ordering cost was number of orders into ordering cost plus it was IM square. So I think I replaced it by Q minus S whole square by 2Q into CH and plus S square by 2Q into CS. So if I ask you that now we have to minimize it, so what are the variables present over here? The variables present are Q and S. The variables are Q and S. So what you have to do for minimizing, you have to differentiate. So for minimum T inventory cost, no, two variables are there, so you will apply partial differentiation. So del TIC divided by, you will do del S equal to 0, you will get one equation, and then you will apply del TIC by del Q is equal to 0, you will get another equation. And same, here are two variables, so I hope you can differentiate easily, but now you have to remember the result. So the result that you will get is S star S star will be Q star into CH by CS plus CH, CS plus CH, CS plus CH. This is the one formula that you will get. And what will be Q star? What will be Q star? Q star will be root over 2D C naught by CH into CS plus CH by CS. So these are the two formulas, and again if someone asks you what is IM star, so you can very easily write Q star minus S star, and the formula that will come out to be, it will be Q star into CS by CS plus CH. And not to forget the final one, that is TIV, that is the total inventory cost minimum. So that will come out to be 2D C naught CH into CS by CS plus CH. So these four formulas are there which you need to remember along with the graph, along with the pattern, the cycle time and these relations, right? So this constitutes your shortage model, and whatever question you get, it will be from here only, and directly you can very easily get the answer by applying the formula, right? Now moving on to the next model, that is the manufacturing model or the production consumption model. What about this? So over here you know that you are not ordering. In this model, what is the difference? You are not ordering, you are instead making on your own. So definitely some setup cost will be involved, right? Some setup cost will be involved. So you are producing and you are consuming. So this cycle gets repeated, the triangle, this gets on repeated. So this is P minus D and this is D, and you know that if you would have only produced, so it could have gone somewhere around here, and you also know that this is your consumption line. So whatever you have produced, you have consumed. Let's say you have produced Q, so you have consumed Q, and this is the rate of pure consumption and this is the rate of pure demand. So you are producing for T1 period, let's say, and you are consuming for T2 period, let's say. So your cycle time will become T1 plus T2. And what is this line? What is this line? This point is what? This point is the maximum inventory. This is the IMAX, maximum inventory that has reached. Maximum no shortage is there as of now. No shortage is there as of now. Okay. Okay. So here also, you know, if I make use of the triangle, so always remember whatever you are consuming at a constant rate. So D into TC, this can be my first equation. And then the pure production one. So how much you are producing? Q. At what rate? P. For what period? T1. So second equation. Again come to this triangle, this one. So I max is equal to, what is the rate? P minus T. and what is the time? T1. So just slope formula I am applying, only slope formula I am applying and getting the results. And the last triangle is this one. So what is the height? Im, slope is d, and into T2, right? So what I can find from here, let's say if I divide 3 by 2, if I divide equation 3 divided by 2, so what I am getting? Im by q is equal to P minus D by P. So from here I am getting one relation, that is the maximum inventory is equal to Q into 1 minus D by P. So this is the one relation of maximum inventory that I am getting, right? And suppose if I have to write that what is the total inventory cost, what is the total inventory cost? So here what I will write, that is the holding cost and plus the setup cost now come into picture. Setup cost. So what is setup cost? Similar to ordering cost. There you are writing number of orders, so here you will write number of setups multiplied by, let's say the setup cost, the cost per setup is CSP. Total demand is D, on one setup you are producing Q, so D by Q number of setups into CSP. And what is holding cost? Similar, that it is average inventory into CH. So what is average inventory? Again you have to see what is average inventory. I gave you a formula that I average is equal to area till which inventory is there. So this is the complete cycle, only inventory is there. So half into I max into TC divided by TC, cycle time. So that is coming out to be Im by 2. So average inventory is Im by 2 into CH. And you can do one more thing. In place of this Im, I can write what? Q 1 minus D by P by 2 is there into CH. So all in all, this plus, if I bring it down, this will be D by Q into CSP, and that will become your total inventory cost. And you know what is the procedure, that if I have to minimize something, if I have to minimize it, so I have to differentiate with respect to what? The variable. The variable is Q over here. So for TIC minimum, I will differentiate TIC with respect to Q. Now I need not apply partial because it is only one variable over here. So dTIC by dQ is equal to 0, and you will get the expression, right? The expression that you all remember. So what is the expression that we need to remember for examination purpose? What is important? So root over 2D. Now C0 I will not write, I will have to write CSP, 2D CSP by CH into P by P minus D. But what is P and D? P is the production rate. What is P? P is the rate of production or production rate. Production rate. Remember, whenever I am saying rate, there will be definitely time. For example, per year or per month or per day, whatever. And the same unit should be for this D, that is the consumption rate, or I can say it is the demand rate. CSP is the setup cost. CSP is the setup cost, and capital D, if I have to say, it is the annual demand. Capital D is the annual demand, and again I am telling you that when I have written annual, it means it is the demand rate, that is demand per unit time, demand per unit time. CH is the holding cost. CH is the holding cost. So this is Q star, and then if I have to write total inventory cost minimum, then it will be what? Total inventory cost minimum, it will be 2D CSP CH, and that just reverse this, P minus T by P, and that will be TIC star. And maximum inventory, if someone asks you, so it can be Q star into 1 minus D by P. So these are the three formulas and concepts that you must remember as far as any production consumption model is coming into picture. So these are the three most important models in deterministic models, right? And you know one thing, that there is production consumption, that there is production consumption model with shortage, that is the fourth model. That is the fourth model. So you can very well imagine that there will be production consumption and shortage, everything is there. In the first one it was very basic, in the second I have allowed shortage, and in the third one I am producing, I am consuming, and in the fourth one I am producing, consuming, and shortage is also there. So triangle, if I have to graph, if I have to visualize, you can very easily imagine that the graph will be something like this. The graph will be something like this. So this will be your P minus D, this will be your D, this will be your D, and this will be your P minus D. Now your entire cycle is constituted of T1, T2, and then T3, and then T4. So entire cycle constitutes of four things. That will be your maximum inventory, that will be your maximum inventory, right? So these triangles you need to keep in mind, these triangles you need to keep in mind. And you know what is the process? The process is that I will write all the cost I will write. After writing the cost, what are the cost here? Holding cost, ordering cost, no, holding cost, setup cost, and shortage cost. Shortage also I have allowed over here, and I will differentiate with respect to the variable. So you know the process, and after I do all those things, the relations that are going to come, those are very important, and that you have to memorize as far as your examination is concerned, right? So what will be the Q star formula? The Q star formula will be root over 2D CSP, 2D CSP by CH into CS plus CH by CS from the shortage into P by P minus D from the production consumption. Entire thing is in root. Then what is the total inventory cost and minimum? So that will be root over 2D CSP CH, and whatever is there just reverse it. So CS by CS plus CH into P minus D by P, right? then if you ask me what will be S star, so it will be Q star into CH by CH, CS plus CH into, I have to just confirm, just a minute. Into P minus D by P. Okay, so Q star is there, TV star is there, and finally if someone asks you what is the maximum inventory, so also remember this one, that here it is Q into 1 minus D by P minus S. So for optimum you just put star over here. Okay. So the 4 formulas are there which is there in production, consumption with shortage. So even if you just remember the graph, how it is formed, and then the the formulae. So this completes your deterministic model, and from yesterday till today all the concepts with formulas we have covered. So this much you just remember. You just remember this much, the triangles you remember, and then you can solve any questions as far as your inventory is concerned. Right. Now my dear friends, see one thing, quickly I will tell you what is your discount model. The next one which comes is your discount model. What is discount model? So one thing you should always remember, that discount model is applied to the basic inventory model. The discount that I learned over here, it is with respect to the basic inventory model, the Harris-Wilson model. Now in discount, what is the concept of discount? That they will give you discount only if you order some quantity more than your a particular quantity. For example, instead of 3 kg, if you take 5 kgs, so they will give you a 4% discount. This is the question. And what they will ask, that what is the optimum order quantity that you will order. Okay. So over here you will see 2 cases. In discount model questions you will see 2 cases. One where your holding cost is constant, and one where your holding cost is varying. Now if it is constant, you can very easily find out what is the Q star. So Q star will be only one, that is 2D C naught by CH, only one Q star because it is constant. And when it is varying, that is when it is expressed as sum I of unit cost. Yes, how it can vary? They will give you that the holding cost is 2% or 3% times of unit cost. That means some I times. So definitely as your unit cost varies, so your CH will also vary. So your EOQ doesn't remain constant, your EOQ changes. So only thing that we can note here is that your Q star changes. Your Q star changes. So if I have to show you from the graphical perspective, what I will show, that for example, if your Q is constant, and here I will show when the Q, sorry not Q, that is the CH is not constant. So for example, here is the total cost curve for different unit costs. For different unit costs, this is the curve. Let us say this is C1, this is C2, and this is C3. Obviously C1 is greater than C2 is greater than C3. C1 is greater than C2 is greater than C3. So clearly you can see that I have maintained one same level for your Q star or EOQ. Why? Because CH I am assuming is constant. Case 1 is CH is constant. Clearly I can say this is the cost curve, this is the cost on y-axis, and this is the quantity on x-axis. And here if I try to show you quantity and is the total cost. So now what we are drawing, that when your CH varies, when CH varies, so when your CH varies, so I will show you. Thank you electrical, thank you. But your name is electrical and you are watching mechanical class, how? Okay. How can you understand mechanical being an electrical? Okay. So 2D C0 by CH, and now CH is nothing but I of C unit cost. So it is 2D C0 by ICU. So all these are constant. So I can say that Q star is proportional to 1 by root I. So as your discount increases, your Q star decreases. Your Q star, if your discount is decreasing, Q star will increase. If your I decreases, your Q, that means inverse relation is there. Right? So for example, C1 is rupees 20. So here if I give 20, say if I give you 2% discount, just a minute. Yes. Okay. So suppose that this is the 20 rupees, and if I give some discount and it becomes 18 rupees, again I give some discount and it becomes 16 rupees. So your unit price is getting lower. Unit price is getting lower. That means if you substitute over here, so something is keep on decreasing. So what will be effect on Q star? Your Q star will increase. Increase. So now why Q star was not changing? Because I have taken fixed cost, holding cost as fixed. Now what I will do? I will vary CH like inverse to 1 by root over I times Cu. So now when Cu will decrease, your CH will increase. That means, and if CH increases, your quantity will increase. That means it will go to the right. So suppose for 20 it is something like this, and this is the Q1 or Q1 star, I can say. This is the 20 rupees curve. And suppose if I give discount, and the unit price will become 18 rupees. So now 18, if you substitute over here, earlier it was 20 in the denominator and now it is 18. So it is decreasing. In the denominator it is decreasing. So CH will increase, and when CH will is keep on decreasing. Why? Because it is in the denominator. So when something is decreasing, your quantity which is there, it will increase. Yes or no? It will increase. Why? Because quantity is nothing but proportional to 1 by I. If the unit cost decreases, Q star will increase. When it will increase, it will move to the right. So now I have to draw something like this, because now now this is my EOQ. You can clearly see that I have drawn in this way. Again, let's say if this for 18 rupees, if I give more discount, it will become 16 rupees. So it is decreasing in the denominator. So that means my quantity will increase, the EOQ will increase. So I have to shift it to the again more right, something like this, right? So clearly you can see CH is constant and CH is varying. If CH is varying, quantity is varying. Okay. So my dear friends, here they will ask you what is the optimal order quantity. What is the optimal order quantity? I'll tell you only one thing over here. Always start from the lowest curve. Let's say this was 16. Always start from the lowest curve. See which is your feasible area and accordingly you start from the lowest curve. That's it. Only one logic is there. For example, this is the question that you are seeing. This is the question that you are seeing over here. So question is nothing. What is the optimal order quantity? If order quantity is less than 500, unit price is this. If order quantity is more than 500, unit price is this. I will tell you, first of all, you should see that whether it is the case 1 or the case 2. That means he has clearly told you that 25% of the unit price, that means some percentage of unit price, that means your CH is changing. When CH is changing, your quantity will change. The EOQ will be different. It will move to the right. So, okay, case 2 curve and case 2 curve. Okay. Now you will always start from the denominator. If you start from the denominator, for example, always start from below. So EOQ, you are finding what? EOQ. So what is Q star? Q star will be root over 2D C naught by CH. But CH is what? CH is 25% of unit price and I will take unit price as 9. So you will get something. You will get something. So I will tell you what you will get. 2.25. You will get 2.25. So you will find the Q star. All the data is given, all the D, C naught, CH, everything is given, and after you substitute, you are getting Q star as 471. You are getting Q star as 471. Now immediately you will see that whether it is falling in the feasible range or not. Simple. You will see that whether it is falling in the feasible range. So when you took your unit price as 9, so you got EOQ as 471. But 9 is valid only for 500 more. If the quantity is more than 500, then only it is valid. 9 is valid. So is it falling in the feasible range? No, it is not falling. Why? Because 471 is less than 500. So what you have to do? You have to move up. It is not feasible. This is not feasible. So you will move to the upper unit price, that is your unit price of 10. Again you will see the same thing. Again you will do what? Again you will find your new CH, that is your 25% of, now unit price is 10, so it is 2.5. And when you find the Q star, it will come out to be, I am saying, it will come out to be, just a minute, 447. It will come out to be 447, and then you will see that whether it is falling in the feasible range. Yes. Quantity is less than 500 for 10. Yes, it is falling in the feasible range. So now what is the thing? Now you have to compare your total cost at two places. Which two places? One at 447 and another at the quantity where price break is happening. So which is the quantity where price break is happening? At 500, and the below one, not above, below one. below 1. See, wherever I got the feasible range, I got the feasible range at unit price of 10. So I will not go up. I will not go up for higher. Immediately I will stop there only. No need of going. Just compare that EOQ and the below price where price break is happening. The price is where price break is happening, but it should be below that. So what below it where price break was happening? 500 at quantity 500. So your this one, and then you will calculate your total cost at 500. Whichever is coming out to be lower, that will be your answer. In this case 500 will come out to be lower, right? So I am not solving the question in detail, I am just discussing the concept. I know that you have solved such type of questions, and still if there is doubt, you can refer the GATE score booster series. In GATE score booster series I have taken a complete detailed question on price break model, right? So this completes your entire deterministic model. This completes your entire concepts of deterministic model, and now only two models are left, that is of probabilistic. Only these two models you have to keep in mind, and then we are good, right? Just a minute. case 2 case 2 case 2 lead time is varying. Lead time is varying. Lead time is varying. So ROL will be D into LT average. LT average and then plus the safety stock. And case 3 is what? Case 3 is what? Both can vary. Both can vary. Both can vary. So if both can vary, the reorder level will be what? I will take the average of small d, I will take the average of this plus your safety stock. So formula is same. If you just have to take the average, you just have to take the average. Now my dear friends, this is the formula, and now we have to relate it with probability. Only one thing you need to know, what? That demand during lead time, and now it has, since I have taken the average, now it has become what? Now it has become ROL is equal to ADDLT plus safety stock, and now you know that demand during lead time is varying. So you need to know only one thing, what? That demand during lead time, or I should say average demand during lead time, follows normal distribution. Done. Done. Only this thing you need to know, that this is varying what? This follows ADDLT follows normal distribution. Remember in part I told you expected time follows normal distribution, and you went completely the problem, scenario changed. You went to normal distribution curve, and here I have written ADDLT follows normal distribution. That means now you will go to the normal distribution curves. Done, right? And second thing I am saying, very easily, just this much you need to keep in mind, and you can solve any problem. And just one thing I am saying, and then you will understand everything. What is how to convert normal distribution to standard normal distribution? I will use this relation Z equal to x minus mu by sigma. So x I can write mu plus z sigma. Yes or no? So just follow over here. X equal to mu plus z sigma, and just compare. ROL will follow x. Mu is nothing but mean. So ADDLT is nothing but mean only. Why? Average demand, average is mean only. So ADDLT will follow mu, and SS is nothing but equal to Z sigma. Yes or no? So if someone asks what is safety stock, you will write Z sigma. If someone asks what is ADDLT, you will say mu. And if someone what is reorder level, you will say mu plus 2 sigma. Done. Second thing, mean. Where is mean in the normal distribution? Where is mean in the normal distribution? So it is exactly in the middle, and that is your mu point. This is the mu point. And after mu, whatever is there, that is your Z sigma or the safety stock. Right? Now my dear friend, the third good thing or the third important point you should know that is that Z corresponds to service level. Z corresponds to service level. But how? How? I am saying Z corresponds to service level, but how? Corresponding to a particular Z value, whatever area is there left side of it, that is your equal to service level. Again I am repeating, corresponding to a particular z value, whatever area is there on the left hand side of the curve, that gives your service level, and area gives probability. Area on the normal curve gives us probability. So for example, z corresponding to 0, that is the mu value. The mu value I am focusing, So what is the area left side of 0? What is this area? What is this entire area? This area is nothing but 50%. So if someone asks you that if I am maintaining only ADDLT, because mu is ADDLT, if I am maintaining only ADDLT, so how much service I am providing? 50%. Why? Because z corresponding to service level. So 50% I am providing. And after this z value equal to 0, after this whatever extra you are putting, that is your safety stock. That is your safety stock. So for example, if I am maintaining this much area, for example z equal to 1, you got the z equal to 1 value. So definitely the service level that I am providing is more than 50. So clearly you can see that z equal to 2, more service level, z equal to 3, more service level, and based on this only we have some standard service level values. So z equal to 0 corresponds to 50% service level, z equal to 0.64 corresponds to this much service level, this much service level. So clearly you can see that when the z level is increasing, the service level is increasing. Why? Because when the z level is increasing, the area left side of it is increasing and I am providing more service. That's it. If you understand, if you are able to understand this relation between z value and area under the curve and service level, then your problem is solved. And then you will face no problem only, no problem, nothing you will face. Okay. So this much you have to remember, this much you have to keep in mind, and I will suggest if you are not able to understand this concept, I request you to please again watch it, rewatch it, and try to understand. If not, you can drop your doubt in the chat section, and I will personally solve it, right? So this completes our third series on revision series on industrial engineering, and all the important topics which I feel is important for the examination I have taken. If you want some other chapter to get it revised, you can let me know in the chat box, right? And if not, then next week we are going to start with heat transfer revision series. Okay. So please revise well and do share it with your friends in case you find it useful, right? So with this we are signing off. Take care. All the best. God bless.